Welcome to Cadence Design Systems Pointwise Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a few minutes. In this video, I'll demonstrate how to create a structured domain with a pole connector. First up, let's introduce the idea of a pole connector. Here we see several connectors. Note that each of these connectors has a dimension, and I hold the mouse over it and we can see what I'm talking about. Over on the left, in the list tree, this one is called con 2-point. You can see that it has a dimension of 10. You can also get this information in the bottom right-hand corner of the window. You can see the name down there, along with the dimension, and the average spacing on that connector. If I go to the second connector here, it's a curve. You can see over on the left in the list tree, it says connector curve. It has a dimension of 10. And of course, this one down here, this weird one that has a circle with a dot in the middle, this is actually a pole connector. And you see over on the left, I have it named connector pole, and it has a dimension of 10. Now, what exactly is this? It's kind of weird, right? Well, this is actually a connector that has a length of 0. It's a little bit strange, but pole connectors have very specific uses, and let's take a look at just one of them. For example, there are several ways to generate a structured grid on a circle. One of the quickest ways is to use a pole connector. So let's go ahead and build one. We have here a circle with a dimension of 20, and I know that because when I click on it, I see over on the left that it is connector 1, it's a circle, and it has 20 points. And of course down the bottom right, again, connector 1, 20 points. Let's put a connector at the center, but not just any connector. No. We're going to create a pole connector. Now how do I do that? Well, I can go up to the Draw Curves toolbar, and I can go to the bottom of that and click on Pole, or I can go through Create, Draw Curves, and select Pole. So we're drawing a connector, and we're drawing a pole. Now, of course, the entity types, the connector is the only thing, because, of course, if you have a pole selected, there's no such thing really as a pole database, etc. So, where are we going to put this? Well, we're going to put it right at the center of the circle. So we're going to put it at 0, space 0, space 0, push Enter. And there's our pole connector. I'll push OK. What do we have here? Well, we have the classic dot with a circle around it. This is the telltale sign that you have a pole. We can see, when I hover the mouse over it, over on the left, we can see that this is, in fact, a pole connector. It's named connector 12. That name is going to be important. And right now it has a dimension of 0. Let's go ahead and change that. I'm going to select it, and up in the toolbar, I'm going to go to where we type in the dimension. I'm going to change that to 20. Since we're building a structured grid, I want all the dimensions to be 20 in this particular case. So now we have to build a 2-point connector, and we'll take that from the center out to the node on the circle. And that's good. I'll push OK. And of course, that dimension is also 0. I could probably change the defaults so that all new connectors had a dimension of 20, but we can change it here manually. I'll push Enter. All right, so let's go ahead and select all 3 connectors and try to make a structured grid using the toolbar button that says Assemble Domains. Now, that failed. And that's basically because we don't have 4 edges. The automated assembly tool there genuinely needs 4 edges to complete. So that's okay, not a problem. In Pointwise, we can do this manually. All we have to do is we go up to Create, Assemble Special, and choose Domain. Here we see a 4-sided structured domain template. This reminds us that all structured domains require 4 edges, and of course each of those pairs of edges has to have matching dimensions. So let me show you how to define 4 edges when we only have 3 connectors, and one of them is a pole connector. But of course, before we go any further, let me remind you that the name of the pole connector is connector 12. That'll be important here in a moment. We're going to go ahead and start with the pole connector. Now, hover the mouse over it. Connector 12 is highlighted. Down in the bottom right, you can see connector 12, the name there. If that was not the case for your situation, you can toggle through the items that are under the mouse pointer by pushing the space bar, but ours is selecting connector 12. And that's the first edge. Now for next edge, we'll pick the branch connector. Notice that it's progressing in a way. It's going from the center of the circle out. You can follow the arrows. I'll push next edge. Now it wants us to define the next edge. I'll pick on the circle. And it's just following logic, right? The arrow goes out. It's going around the circle, it comes back to this node, and of course for the 4th edge it has to come back towards the center. So we'll go ahead and select that again, select the branch connector again, and it automatically completes it for you. We'll push OK. So what do we have here? Well, we have a domain that is basically filled with quads, but these central cells right here are actually structured quads with a degenerate or a collapsed edge. So if this were going to be exported out to a structured solver, that's how it would be treated. Not all structured solvers can handle poles though, so if you're using a structured solver that doesn't support poles, then you'll need to rebuild this domain without a pole. If you are instead to export this domain as an unstructured domain, then these central cells would instead be exported as triangles. Now we do have an additional video that takes this concept with the pole connector and it takes it into the third dimension, where you not only have these pole connectors, but you have pole domains that make blocks. I've placed a link to that video in the description below. Now, at the start of the video, I mentioned there were a few common ways to put a structured domain on a circle. Another method, one that is often preferred, is called the OH topology. It's essentially 4 domains around the outside with a relatively rectangular-ish domain in the middle. This is sometimes called the butterfly topology. Now, this technique eliminates the pole by creatively using a few domains assembled in a way where you don't need a pole. Thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.